Good morning, everyone. It is 10 o'clock on April 27th. You have entered the Washington and Seattle 2021 Energy Code Update Series. Yay, we got Duane back, and he brought Nick to help with this one. On envelope is what we're starting with this spring. So I am Katie from the Lighting Design Lab. Happy to be in the background here with you, and I'm gonna let Duane and Nick take it away.
Well, Katie, do you want to go through your city light slides?
Sure, I'll do that. If you haven't had a webinar with us in the past couple of years, we have everybody on mute, but you have chat available to you in some sort of toolbar, maybe on a separate screen. Take a look for that chat. Ask the question anytime, and we'll break in and get an answer for you. There is a short survey at the very end when you close the webinar. Please take that. That helps us improve. We take your feedback really seriously. Education is what we aim to do, so we need to know we're getting you educated. And at any time after the webinar, during the webinar, reach out to us at Lighting Design Lab at seattle.gov if you have any questions about our programs.
How about use of the chat?
Yeah, use that chat anytime. Questions will come into the three of us that you see right here, and we'll answer those as we go along. And just a reminder, Lighting Design Lab is part of Seattle City Light. I've worked for City Light almost 12 years now, but today we have our partner department, Seattle Department of Construction and Inspections, and subject matter expert from NBVJ. So thank you both for your partnership and helping our educational constituents learn some stuff. We have a lot of people signed up today.
Thank you, Katie. Okay, and welcome everybody. This is the first of 5 we've got lined up, and we might add more special interest webinars after that. Note that this is one of a whole raft of codes for any of you on the call who might be newbies. The energy code's just one of them, and somehow everybody's got to wrestle all these for every project that you do, and so let us know if you got ideas about how these all interact. Just to be clear, we're calling this. We're perfectly aware that this is 2023. It's the 2021 IECC nationally that this is built on. Then the last couple of years, Washington State spent pulling together its changes. We have like 200 amendments or something like that. We make all but one, I think, which is to make it more stringent. And then once that's finalized, Seattle picks up and does some more things. We often lead the rest of the state. So things that are in the new Seattle code are likely to find their way in some state into the state and eventually national codes. The July 1st is the date for everything outside of Seattle. Inside of Seattle, we had been expecting to get to July 1st right up until about 2 weeks ago. And then since it's Seattle and since we can't help but review things to death, we're doing more internal reviews and talking to more stakeholders right now. And so we bumped this to October something. They've just, as specific as they got was no sooner than October 2nd. And part of that just has to do with getting back onto the city council's calendar. One little thing you see in red there, what we call commercial buildings historically has excluded 1, 2, and 3-story apartments and condos, and those are now included. Not townhouses, not single family. We won't talk about those at all today, but but in the residential buildings part of the energy code now for the state, it says for any height multifamily, go see the commercial code. So I just wanted to mention, in the code, section C402 is our envelope part, and it looks kind of random, but really over on the left you see that there are a bunch of things about the opaque envelope, and then on the right you can see that there's at top a bunch of things about fenestration and then about air leakage, and there's many miscellaneous topics tucked in around there, but that's sort of the general direction. Anybody that's been on these programs for the last several years has seen this slide. What are our targets statewide and citywide? We're committed legislatively to meeting some aggressive climate impact goals, and those have actually been beefed up at both the state and the city recently. The big thing in the lower right there, which we're still working on, is the details for the building emissions performance standards, which will layer on top of the state building performance standards, but being focused on carbon emissions instead of just energy use. So, and you've also seen this slide, the big four directions we're taking in the development of the Seattle Code today being that number one, the building envelope of any building that you're designing now is going to last longer than anybody on the call is going to be alive. So, and we're supposed to be a carbon neutral city in 2050, which actually might be getting moved up even earlier. And so we have to build building envelopes during the 2020s that won't require any major surgery to work in that carbon neutral Seattle. There's a couple ways to approach building envelopes, and the building envelope serves a couple of major functions, which I categorize as separation and connection. And so you can see the building on the upper left, great example of separation and really low solar gain and good thermal mass and privacy, security, you just love it. But and the one down in the bottom, I would love to see Philip Johnson's gas bills for Connecticut in the winter, but great connection with the outdoors, and we're always going to have that tension back and forth between how much of each we're trying to do. One of the reasons, and there are several, but one of the reasons that I don't get invited to dinner parties is that what we're talking about here is it can be really dull, because what could be more dull than caulking and blown in cellulose insulation and like that. But unlike the other systems in the building, which get replaced on a regular basis and sometimes work properly and sometimes don't, once you build in that envelope, it is just there pretty much forever. And we still have a number of high rises downtown from the late 50s and early 60s that still single glazed, unbroken aluminum curtain wall, and that it's been a long time since those went up, and it's going to be at least that long that your current envelopes are going to last. It's mostly about whether how much and how much glazing you have and how it's treated. Sun coming in and overheating in the summer has got to be dealt with energy use, and obviously heat loss all winter, and really a lot of our spring and fall as well. The air leakage and conduction are also issues, but really that everything gets dominated by glass. Like I said, our buildings are going to be around for a long time, and so not only make them thermally great, but please make them look good. We've had now 4 entire generations of architecture professors drooling over that image on the left from 1922, that all glass see-through building, and a lot of my architect colleagues just can't get over it. But it might be time to get over it and still find a way to make a stylish building. It's funny that people doing all glass towers think of themselves as being creative. But anyway, Nick.
Yeah, and by the way, I'm Nick McDaniel. I'm an architect at MBBJ, and I've been fighting or arguing with Duane about energy and architecture for a little over 20 years. So we've got a long history of talking through these issues. But one of the things that we're really finding at MBBJ is that the sense of beauty has really moved on from those all glass buildings. And so more and more the buildings that we're celebrating and finding celebrated in the architectural community are buildings that aren't all glass, and buildings that express their performance as well. And so, you know, I just put several of kind of the recent MBJ projects that really celebrate something other than glass, from the thermal TC at Microsoft to Samsung's headquarters to REI's headquarters. You know, these are all projects that really express their performance in the skin. So it's the new beautiful.
Cool. It does. This all begs the question: where are we going with this? You know, how good of an envelope is going to be good enough for the long run, and for Seattle to basically be teaching the rest of the country and sometimes the rest of the world how to do it. There's I list several options for how we would come up with this conclusion about how good is good enough. Is it a cost effectiveness thing? You know, thermal balance points in the past have been that's the point at which you have to start heating the building. It's been up, you know, around 60 in the past with some of our crummier buildings. It's getting down, I think, below 50 now, but we might push that further. Anyway, it's an unanswered question that we have to ask about. You could always make a better and better envelope. Are we going to say, okay, we'll just buy the whole passive house thing, or is there somewhere else that's going to be more effective? and here's my reorganization of Nick's slide.
That's awesome. So people can actually read it. That's great. Duane asked me to quickly talk through how we do UA calcs, and what's been interesting is the entire time I've been at MBBJ, every year somebody has come up with a better way that's supposed to work to do UA calcs. And the real bottom line is that we've never been able to figure out a better way to do it. And so literally we have to go through the entire building, face by face, surface by surface, through all the plans, all the elevations, and draw on the UA for each one, and then reach out, you know, to somebody like an Arup to calculate all the assembly values. Obviously, I'm talking about bigger buildings, and then finally go through Duane's wonderful Excel spreadsheet that has also probably been around as long as I've been at MBBJ, and figure it all out. It's incredibly time intensive, incredibly difficult, and more we're seeing projects move away from it, and to try to meet the prescriptive calcs instead as a real way to save money and time on jobs.
Nick, what is that little thing in the upper left?
Oh, that's a crazy plan. It was an example of how crazy the plans get as you try to figure out all the different layers in a building, and try to figure out what the different assemblies are as you move through it. It's a real effort. Very, very painful, very time consuming, and of course the design changes, and then you do it all over again.
So Nick, when I left NBBG a dozen years ago, we were right on the verge of having
The perfect
control in Revit that would spit out what the UA was for your building, right?
Yeah, and believe it or not, we've been trying to do it for a dozen years, and the bottom line is that it's so complicated between heated and unheated spaces, parapets, corners, edge of slab, all of those different things, that in the end, what it really takes is a really experienced architect going through and figuring out exactly which assemblies match to which areas. And it's just, you can get an idea. You can see how many assemblies, each color down there represents a different assembly on the building, right? In that kind of bottom little chart there. It's really difficult, especially on your bigger buildings, and is an enormous time sink and waste of time in a lot of ways.
Well, I'm always happy to waste time. So getting into the code itself, the maximum allowable area for the state code is the same as always. At the baseline code it's just a straight 30%. Seattle, it was suggested, and we finally bought into this, that we use a variation of the chart that's ASHRAE has with a different target glazing percentage for each building type. So it's different, and you got to look them up in the table. There's the table. I highlighted schools there, so that would be 26. This is after some long back and forth with some school design people saying, well, in the ASHRAE chart it says 22%, and they based that on a survey of a lot of schools that was kind of an average. But they said, given the importance of daylighting, it should be 30. So we settled it halfway. But that's so some of these that you see highlighted in yellow are higher than what's allowed by the as the ASHRAE standard, and we'll go for there. So just beware if you're an energy modeler that this list is not your one for the energy modeling. Just wanted you to see it graphically. On the left, you see Washington's code. So 30% you can see is the baseline for everything. And if you use high performance glazing or one of the other options, you can get 40%. With Seattle, you're going to find out in a minute that we require a small percentage of your glazing to be triple or equivalent U-value glazing. You can have, for different building types, different occupancy types, you have different allowable glazing percentages. And then there's an option that if you want to, instead of 20% of your total glazing for the new building being triple, if you want to go to 35%, then you can bump all those up by 5%, as you have larger allowable area. And if you go to the high performance glazing plus, which also has to include that 20% triple glazing, then you can go even higher. With a large multifamily, you can get all the way up to 50%. And that's even these are the baselines. And so if you do better than this, you could use a UA Calc methodology to increase it somewhat further. So those are, I mentioned we have new glazing percentages. So notice that for Seattle and Washington State, the baseline is the same for both codes, but it's tighter than it was for last code. I think the state code picked up what the Seattle code values were for that baseline you see on the left. Then Seattle has a column B. Can we show that? Yeah, well, and that is for, so the first one, the column A is in Seattle is for the 80% of your glass. Column B is for 20% or 35, depending which, and that has U values that are intended to push you into triple glazing. There's still some people saying, well, we might be able to do that with some super duper double, and actually more power to you that if you can make that fly. So that's the big change here is that, and the intention with having 20% V triple glazing is to make sure that all the industry players, all the fabricators and installers and everybody is doing triple for all the buildings for a few years. And then presumably next code cycle or the one after that, that will be stepped up to a higher percentage. I'm still thinking, the big show windows you have to have for your ground floor retail, that's, that would be really challenging to do in triple. So maybe it will never hit 100%, but the idea is that this was our last big chance to bring envelope up to high performance. And there you can see it graphically. So you can see on the left is what we had for the 2018 code is the Washington and Seattle codes, the Seattle ones being the same or better. And then on the right, you can see Washington and the Seattle code. Notice that it is the same for all of these, the top one being, top two being operable and fixed site built, by which I mean curtain wall, storefront, ribbon walls like that, and the bottom two being punched, operable and fixed regular punched opening windows that are manufactured in a factory. It's the same for Washington State and Seattle for the baseline, and then Seattle has that additional column on the right for 20% of your glass to be a better U value. It doesn't have to be traditional triple glazing, although that has fallen in price remarkably lately. There's something that Lawrence Berkeley Labs helped develop over the last several years called thin triple, where they use, you see that upper right there, there's a pane of glass in there that is the same glass they use on your laptop screen, protected in the middle there. It's the same width of a glazing system as a regular double pane. Those are, I think there are 3 manufacturers that are making those glass panels now. There's that one on the bottom right, the vacuum insulated glass, where they have those little dots that hold the panes of glass apart. I've noticed that you can if you stand back about 5 or 6 feet, you don't see them anymore at all. But those are, so we're not saying you'd have to have triple glazing. It might be that there's some other kind of cool glazing that people like, but does make a big difference. Nick.
Oh, sorry.
Oh, go ahead, break in.
We have a question about glazing. How does the requirement work for mixed use buildings?
So for mixed use buildings, each section of the building would follow its own its own path. You're talking about up here, so you got retail on the bottom, and then you got some office floors and a hotel on the top or whatever. Each sector would follow its own, and if it's a smallish usage, say say you have healthcare with a small retail in it or something like that, then you just the whole floor would follow just the main occupancy type. Was that it, Katie?
Yep, that was the question. Thank you.
All right. Nick is going to explain why there's a gorilla on this screen.
So, Duane, part of my job is just to bring in kind of industry costing and reality on things, because I just do a lot of square footage in the area. And really what we're finding is that the triple pane is not very cost prohibitive anymore at all. And so the latest numbers we're starting to get are about a 15% premium. And what it does is pretty amazing. So, with just a super standard, plain Jane curtain wall system, with nothing particular special, a triple pane we're finding gets down to about a 0.19 U value. so incredibly low.
So,
And
that's already below that
column B.
standard that we
Yep.
set for column B.
Yep. And so if you imagine, it's a very cheap way compared to the kind of amazing things that you'd have to do, you know, going to a fiberglass curtain wall or other things to try to get that kind of drop in U value that you might see. The other thing that we're finding is that with triple, you can really craft the glass because you have more surfaces to work with the low E's. And so you can really refine your glass to get exactly the right daylight U value balance that you're really looking for, and you can really do some pretty amazing things. And you know, I just put a picture of myself kissing the glass because the glass has been so good on so many projects with this that I'm incredibly excited about it. So there you go. There's your explanation, Duane, of why it's there.
Thanks. I thought you're just admiring your reflection there.
Yeah, there you go. It's
so. You probably saw a few slides back that that there's on that far right column there, we got high performance glazing with so that high performance fenestration, if you just look at the red text on the bottom, that bumps you up to an allowable 40% of glazing for every kind of building outside of Seattle. Inside of Seattle, you have that allowable area from the table plus 15% if you're an R2, apartment or condo building, and it's the table value plus 10% more if you're any other kind of building. So you can, and we set these. If you look at this slide, we set on the right, there's the high performance. You'll notice that the column D in there, I call those columns C and D because having another column A and B would have driven everybody crazy. So, but you'll see that the far right-hand column, those values are all the same as they are for column B in the regular glazing. But what's different is that the other 80% of glass, we set those values halfway between the triple pane value and the base code value. So if you want to have even more allowable glazing area, the 80% of your glass has got to be that really extraordinarily high performance double glass at least. I think I passed by something here. Yeah. So those are the values. They're 0.26 for the fixed windows in general, and for any kind of site built, so curtain wall again, and then 0.22 for punched openings. That's your high performance, and then over on the right, it's the same for your triple glazed 20%. Yeah.
So Duane wanted me to talk a little bit about how hard this is, and I guess my thought is that especially the 0.26 is really within reach right now with a double glaze, just a simple double glaze with low E. And I think, we were able, NFRC tested to get down to a 0.28 on a recent project I just did with just a number 2 and a number 4 low E. And, if you're careful and judicious about picking your glass and your low E's and have some reasonable thermal breaks in a pretty normal curtain wall system, you can get pretty close to this already. And I would think that you could get down there with just some simple additions and changes. So this is not hard. This is not hard to get to.
Nick, what kind of values would you get if you were doing silicone glaze instead of having an exterior cap?
Well, in this case, this is silicone glazed. So I think that's important to say that this is a butt glaze system right now with a number 2 and number 4 low E. the cap adds a bit, right? 0.02, 0.03. And so I think you want to look really hard at whether or not you want to add those caps to your system, because a lot of times a butt glaze can be a really beautiful look. There's ways to break the caps that you can make sure that they're separated if you want that look, if you want fins or other things. But if you just think hard and look at this hard, you can really cut down on that thermal bridging and get there with really standard systems, standard curtain wall systems.
So this 2.8, to get that one down to a 2.6, is that an argon filled or?
That's an argon filled. I mean, everything we do, right, is argon filled typically. Really, it's going to be, I think you'd start to look at, super spacers. You'd probably try to enhance the thermal break in the curtain wall a little bit, would be my guess, to get that additional 0.02. But it's not, that's awfully close, right? A 0.28 to a 0.26 is a very close jump.
Thanks. So just wanted to say that Seattle seems to be the only jurisdiction, even though nationwide NFRC label certificates are typically required for site build stuff. We're one of the only places that enforces it, but we do. And in fact, there's been some leadership changes internally here, so they're going to be enforced even more carefully. So the trick is that, manufacturers will grudgingly show up with these months after the fact, unless you're really clear. So if you're having pre-bids or pre-installation meetings, or for that matter, while you're writing your specs, make it really clear that they gotta have this label certificate for the system into the building inspector before you start installing the system. And it's got to show that, in fact, yes, this system you're installing meets what you promised to do in your bid or your permit documents. So there's been a lot of misunderstandings. Obviously, the worst possible thing is that you get something up on the building and then it's over the allowable energy flow, and you're going to have to do something to make up for that. So just word to the wise, make sure you get that label certificate early. There's no reason for them to delay.
Well, I'm really going to continue on that theme. Recently I had a project really far down the road in design where they did the simulation and we met energy code, and then they did the physical test and they didn't meet their simulation. So that suddenly we were looking at worse U values or higher U values than we had done, and had to do a bunch of redesign, right? Really late in the process. So a couple warnings about NFRC that sometimes people don't realize is that it is a set size. So it's always the same square size of the testing that they do, with the one vertical in the middle. So this is what a typical curtain wall would look like on the NFRC, but on the right is what the actual design was. And so what happens a lot of times is that the U value of your building skin is going to perform better in reality than your NFRC because of that strain, because of that size and mullion breakup. That's frequently a lot more mullion and metal in the system than you really will have. I guess the other could be true too. If you had tons of little tiny squares and lots of metal in your system, you might do better on the NFRC. But it's important to know these NFRCs are hard. They take a long time. You need them in early so that you can understand, the energy of your building, and so that you can design your building and not redesign it multiple times in the process.
Cool. And if you're doing punched windows, it's a lot simpler. You just have the sticker there. There are a bunch of values that some people find in Chapter 3 for various kinds of windows. Do not use those unless you have, there's sometimes odd situations where you're reusing salvaged windows or something like that, and you don't have any NFRC test, you have to use those, but otherwise always go with the label. This is my little pet peeve. That diagram on the left shows what I'm calling the heat loss superhighway, which is that same stick of aluminum that is out in the warm air inside at the top there. That same piece of aluminum is now down in the spandrel area. It's got an outer face that is completely uninsulated. So you're taking, and aluminum, as you know, is a wonderful conductor of heat. So you're taking you got three sides exposed on the top to absorb heat from your system, and then you've got a great place for it to flow out of the building. Recently, look on the right there, you can see that there's a system with continuous insulation outside of the spandrel and a frame extender by the manufacturer that puts the glass out there with it, and that means that gap for the heat to flow through is gone. Didn't put that in the code this time because there weren't really enough manufacturers doing it, but I see this is coming on, and I could see that's a way around that problem. But otherwise, we've considered the spandrel and the vision glass areas separately, and it looks very innocent, but it doesn't work. And there's this other thing about condensation.
Yeah. So one of the things that we're finding that's new for us is that, you know, curtain walls are not fantastic in terms of their U value. They have those metal superhighways that Duane was talking about. And so one of the ways to meet code then is to add insulation behind the curtain wall to try and get up to the U values. So we've started to frequently put continuous insulation as a layer behind the curtain wall to get the insulation up. But the other problem with that we're starting to see is you can see these condensation diagrams. If you imagine the pink to blue is your dew point line, and what we're finding is that typically what we would always do on a curtain wall system is the vapor barrier would happen at just the back of the mullion. So that one trade, if you imagine, the curtain wall manufacturer is doing your air barrier, your curtain wall, and your vapor barrier on the back. We really, really love it when that's all one trade. But the problem is that when you add that insulation on the back and you increase that U value, you create real risk of condensation on those cold mullions that are kind of close to the slab top and bottom. And so in turn, what we're having to do is move the vapor barrier in, which means you've got a new trade coming in typically when they install those walls, putting vapor barrier in. And so this is just an issue to be aware of. It's pretty subtle and it's pretty difficult to find. You have to be pretty far in design before you're going to discover it. And really important to write into your specifications a requirement for your curtain wall manufacturer to do this condensation analysis.
And if you don't believe Nick, I would suggest you have a heart-to-heart talk with your insurance guy. So this is something that's been unique to Washington State and Seattle codes, but is now moving into the national standards, and that's that you cannot use energy modeling. Notice that's the section number up there, C407 is the energy modeling section, to make your building envelope dramatically worse. So in the Washington State code, you can't make the UA of your building be any more than 20% worse than prescriptive. And in Seattle, we've cut that to 10. I had it at 0, but I have various friends who can pull me back from the edge of the cliff. So that we're really saying since the envelope is so important, it's going to last so long, and really the trade-offs have been pretend in the past. People have since nobody uses up their entire lighting power allowance or their fan power allowance, and nobody installs an 82% efficient boiler anymore, they can take all these things they were going to do anyway and say, oh, look, we're better than code in these areas, and therefore we can use that credit to make the envelope worse. And we're saying, no, can't. And by the way, that bottom piece there is to clarify that you can't that you can't just use energy modeling to get out of that 20% triple glazing. You still got to have that high performance glazing in your design, even if you're doing energy modeling.
I think this is a great point, Duane, in that this is part of why we're starting to see even some pretty big projects go to prescriptive on the energy code. Because by the time you do all that modeling and do all those UA calcs I was talking about before, you're going to have to really see some amazing benefits from that for it to make sense. So
yeah, you could make your building a lot worse, and that made owners happy.
Right, there used to be a lot of benefits you got out of it, and now it's like, well, I don't know if you're getting quite so much. So this was just a thought about Windows, at least for now, they're getting better, as Duane pointed out, but transparent glazing is bad. It's tremendously, compared to solid wall, it's so much more conductive, at least with the best technologies we have now, in the 10 times kind of area. And so really thinking about where you put your glass is becoming more and more important. And this kind of goes on the vein I was talking about less and less glass on buildings and really enjoying buildings that show their performance. So in this example, what the building has done is we've done everything we can to get a 10'6" window head height. So a very high window head height to get the daylight autonomy we want. And that's what you really need to drive daylight deep into these buildings. But you don't need it in a ribbon all the way across the building. And so if you can add vertical solids in between each of those windows, even on a high rise, it makes a tremendous difference in the energy efficiency of the building, and then also allows you to get that really great daylight autonomy that you're looking for. So we can have both. You just can't plaster glass everywhere anymore.
Nick, can you tell them what's the difference between the top and the bottom of that middle diagram?
Yeah, so in this particular building, we looked at basically we're getting shading from surrounding buildings at the bottom. So you're seeing an insolation diagram in the middle of sun hitting the building. And so what we did is we designed the amount of transparent opening to be basically most opaque at the top and most transparent at the bottom, so that you got the same daylight autonomy on every floor on a 40-story tower.
Got it. So we're looking at an elevation.
You're looking at an elevation, so design your glazing and your fenestration to maximize daylight and minimize conductance. That would be the thought.
Well, that's totally cool. I just put this slide in. I've put it in previous things, and my main point here is what I write at the top, that this is an example of somebody who had to have a vestibule, and you see so many of these, and they just like use some curtain wall framing or whatever and put this thing in, and it's boring and kind of tedious. And we have a lot of architects on the call. I would just challenge you to do something cooler than that. But you do have to have a vestibule for any way that people typically go in and out of the building. You have to have a vestibule for those doors that are next to your revolving doors. I did a little informal survey once, and it's somewhere around 40% of the people in a few buildings I looked at were going through the swing doors instead of the revolving. If you really don't want this, air curtains are a possibility instead. They're actually quite effective if you follow the rules. But we have the 3,000 square foot rule, so that means if you're doing a little coffee house that doesn't need a vestibule, obviously that a vestibule would be a large proportion of the coffee house entire floor plate. If it's just an emergency exit, if it's the way from your restaurant to the outdoor patio or whatever, those are all exempt. we have a couple thermal bridging standards in, one regarding cantilevered concrete balconies and another fenestration. This is in what's the current code and will continue on into the new code. And these have been big pathways for heat to get out of buildings. And we do say we've set this up so that what I've got highlighted there, you can use that one of those commercial systems that has an R10 thermal break. You can see in the middle of that upper photo, and that can have stainless steel reinforcing running through it. But if you want to use a regular cantilevered slab, you have to go back and use that value from the tables in the back for uninsulated concrete walls, and that is 0.74 as opposed to a 0.05 that you'd have for a typical wall assembly. So it's a big penalty. And there, I'm just comparing a radiator from a Ducati motorcycle and a couple of buildings that are going up right here in Seattle right now. Look at the similarity in the proportions. It's just uncanny. But the radiator is designed to help dissipate heat out of the motorcycle engine as efficiently as possible. And those high rises, I went marching into our plan review people and said, "What the hell is this?" But they said, "Back off, Duane. It was a 2015 code project, so they were still allowed." I did, though, do a tour of balconies around town in several neighborhoods, looked at a few dozen buildings, and remarkably, since this code change, I only saw like 1 or 2% of balconies being cantilevered concrete. The rest, in order to deal with this rule, there's various kinds of clip-on balcony systems you can buy, or they're recessed so you don't have to cantilever, or they have angled braces that are used in places that pick them up. There's a lot of options there, but here's an example of a code requirement changing construction practice, and people that want balconies can still have them. There's that second one was about glazing, and if you just look on the diagram on the left there, the main thing is that you got continuous insulation outside of your building, and you got to have the glazing within 2 inches of that. Otherwise, you're opening up this big pathway for heat to flow out through there. If you've spent a lot of time around architects, you know that the idea of having the shadow line gets people all tingly, and you just got to be aware that shadow line comes with some kind of cost. So there might be a technical way you could work around it if you really wanted it, but the code says no. You gotta hug those in close together. The glass and the thermal break in the framing system needs to align somewhere with, near the continuous insulation. You know, I'm going to just skip by this, and we might come back and have a break in a little bit, but I think we're.
I wonder, it said, Duane, on the questions that we were going to answer questions at break. There's a bunch of them.
Well,
Yeah,
okay, let's take advantage of that then.
there are a few. So going back to U values, Cameron is curious what you guys think the max, like realistically achievable U value would be if, as you're saying, U26 is relatively easy.
What do you think, Nick?
I guess the question would be max U value with double pane, or right? You know, what's the minimum? I guess probably minimum value is the question. You know, with a with right now with the technology as it's at, with a double pane window with argon, right? You know, I'd say about 0.25 is about as far as you could possibly get until you go to something really much more extreme. That's just my gut.
Talking about a curtain wall system?
Curtain wall, I'm talking about curtain wall system, aluminum curtain wall system, double pane, low E number 2, number 4, argon, super spacers, and then some kind of reasonable thermal break on the curtain wall itself in the system. That's about butt glazed. Sorry, there's a lot of caveats. But I mean, that's about as far as I could see you going with a straight system. Obviously, once you go to triple pane, you can get it quite a bit lower than that. So that
Everybody should keep in mind that don't get carried away when you're looking at glass data, because it's not the glass, it's the whole system. So the glass will always be better than the system thing because it doesn't have the metal interruptions. So this is the glass value will be much lower than the 0.25.
it really is all about aluminum. And just one last thing to think about is what we've really found is if you can cut aluminum, so if you can figure out ways to, for example, we use 7.5 foot units instead of 5 foot units on our curtain wall, that right there is an enormous savings in U value, in embodied carbon, and also then in kind of the performance of the building and speed of erection. So if you can cut aluminum, you can cut U value is the general rule, but it's the aluminum that's the problem in a curtain wall system.
What's next, Katie?
Another related, if U28 is easy and U26 is very close, why not make it simpler for the industry and use 28 instead of 26 in the code as the target?
That would, this was a product of a lot of public meeting time to come up with these values. And the idea was to get, to have values that move the system forward, so that we're in Seattle and in Washington State getting to ever more efficient buildings, getting down towards that carbon neutral goal. Not sure if that answered the question.
That's the hard thing about having questions in the chat is we don't get to have a back and forth. But so the next question was asking about the 15% premium for triple pane. Is it across the board or just in specific categories?
Nick?
So the 15% is what we're seeing as a plain Jane curtain wall add. Obviously, if you get into much more complex systems, that'll go up, right? But just as a straight replacement for a double pane to a triple pane, the cost of that has gone down, down, down. So I guess to answer that, I don't know if that answers your question, but that's talking about your typical straight curtain wall system.
And we've heard similar numbers for manufactured windows. What's next?
Okay. I think this was just going back to codes getting, ever tighter. Does that mean that the 2050 code would be design envelope equals code prescriptive with an ever increasing prescriptive requirement?
At a certain point, and we're getting close to it, I think that if we took this triple glazing thing and we brought it up to say 80% of the glass in a building instead of 20, and we had the other envelope values the same, the question is maybe at that point going any further would just not have sufficient returns to make it sensible. So barring technical developments that make even more high efficiency possible at an economical scale, at some point in the near future, I think we max out on how good we can make an envelope. And it won't, I don't think that trend line will continue from here to 2050. I think it'll continue for another code cycle or two at the most.
Okay, we have two more. Ready? Steve is wondering how long the argon gas lasts inside windows and curtain walls.
Not forever. Nick, do you have an answer on that? Do you know?
You know, I don't know. We don't ever talk about that. I do think it's really important as architects for us to be looking at this stuff. So for example, I put vacuum insulated panels in one of my projects. And then we went back 5 years later with a thermal scanner, and you could see which of them had failed because they were big and red, right, on the thermal scanner. And I think with all these technologies, everything leaks over time. And so anything you put in that IGU, I would guess over time comes out. And I think it would be really important to look at. So I don't know the answer, but I can tell you that over time, you know, nature abhors a vacuum. So things change and move.
Literally. And I did see one time a system that had a built-in fill tube that was meant that at some point in the future you would go and recharge the argon, but that's not typical. But it's a good question. And one more, Katie.
Last one. Okay. So let's say there's a tenant space on the lower floor of a multi-story R2 building, but the build out is a grocery store. Do they need to revise the glazing for the actual use?
So the ground floor, try that again. The ground floor is an R2?
The whole building is a multi-story R2 building. The build out on the ground floor is a grocery store.
Yeah.
Well, I'm not sure if Paul means the grocery store or the whole building. Do they need to revise the glazing for the actual use, I think, of the grocery store?
Yeah. The idea would be that the ground floor would be planned for some kind of retail or restaurant, and those it would be wise to make sure that your glazing fit that type of occupancy so that you could lease to whoever you wanted. Note that in Seattle, a lot of our buildings are built along streets where we're required to have large glass areas facing the street, and there's exceptions for area in there, and so you wouldn't necessarily be constrained to a reduced amount of glass if you're in one of those areas.
Great, that's it for now.
All right.
Somebody just added one last one. I don't know if you want to hit that, Duane.
Go ahead.
It just says, what will happen with existing buildings undergoing a major renovation that will require meeting the current code? Does the envelope need to meet the new code requirements?
The overall performance of the building, it would need to meet the energy code requirements minus 10%. If you're, and I think we were talking about a substantial alteration, right? So you're doing a complete gut and rehab, or you're changing the use of the building or something major like that. And we recognize that there are a lot of things about an existing building. You're not going to be able to insulate the slab edges, right? I mean, come on, some other things. So we accommodate that with our little 10% thing. But no, for those kind of projects, we're treating them as though they're a new building, not just for energy, but seismic and life safety and some other things. And then we back off somewhat, you know, based on the reality of that situation. So you may indeed need to get up to speed. Notice that we have rules coming into coming into play statewide and in Seattle that for building performance standards, and those building performance standards are going to start kicking in the next several years, and existing buildings that aren't doing any renovation at all are going to be required to meet those standards. They are not as rigorous as the new code, but you can see that some of our older single glazed funky buildings that have enormous heating and cooling energy use are going to have to get some serious upgrade to the building generally, whether you do it to the envelope or to the mechanical systems, or some combination would be up to the design team. And it's a really good question. We'll have more, we're still working out the final versions of the building performance standards for Seattle, but the state one is already in place, right? And it says that starting in a couple of years with the largest buildings, you're going to have to meet these, bring below average buildings at least up to average performance for energy. And Seattle will layer on top of that requirement that over time you have to reduce the carbon emissions from the building so that by 2040 or 2045, those carbon emissions are down to zero. And so obviously you can't keep burning gas forever if you're getting down to zero carbon. So got a few things to trade off there. And later on in the talk, we will talk more about existing buildings. Here's a mechanical slide, and the only reason I have that here is saying we have this requirement for heat pump heating, and then we say, okay, in apartment buildings, you could have 750 watts of electric resistance per room, and the question is, okay, if that saves you from having to have little heat pumps all over the building, what does that need? We had a similar lecture last year. RDH helped out with that one, and they looked at the last year's code and how this would work, and found, okay, you can have normal glazing for an apartment and still work within that 750 watts really conveniently. And now that our U values are even a little tighter, you'll have an easier time meeting that than ever. For a large corner room in a curtain wall type like building, these are more difficult, but you could do it by having better U value glass. Well, lucky us, we have better U value glass built into the code, and you could, if you have certain challenging areas of the building, maybe you'll use those when you select which portions of the building get their triple glazing of the 20%. Another thing in the mechanical aspects of this code is that, and this is also from in the current code, so it came into effect a few years ago, that you've got a balanced ventilation requirement in it for apartments. So what I put in bold there, what we used to do for a lot of buildings was trickle vents in the rooms, that little slot at the top of your window that let outside airflow in, and a continuous bathroom exhaust taking it out the other side. That was really unpopular during our wildfire smoke season. But we also found that for even medium height buildings in cold weather, this made the ventilation work in reverse due to stack effect. So the top half of the building was actually having air flowing from the core of the building under the entry door and out through their trickle vents. So anyway, now you have to mechanically deliver ventilating air to each habitable space, and have heat recovery on the exhaust. So on your left there are three options. One, you could have one of those little heat recovery ventilators like you see in the picture in each apartment. That means that somebody has to come in once or twice a year to change the filter on it, which, you know, those kind of invasive service things are not always popular with tenants. And there's lots of little holes in the wall. The second idea is that you could, for each stack of units, you could drop down vertical shafts. You don't need a lot of air, but the shafts, you know, do take away a few square feet of area, which developers would rather be renting to someone. You'd have fire damper problems. You'd have these rooftop units that might compete with other things that people doing multifamily want to do with their roof. And finally, the idea, which I think is my favorite, is that at each floor, you know, maybe at each end of the corridor, you'd have a heat recovery ventilator that served a half dozen units, and that would mean that there was only 1 or 2 penetrations per floor. The maintenance would happen out in the corridor, so you didn't have to invade the apartment. That might be the way to go, but you can see how that impacts your envelope, the number of holes that you have to do and where you have options to make those happen. Another thing that's in the current code and for Seattle and now has gone into the Washington code is that PTACs, you know, if you've ever been staying overnight in a cheap motel and you had one of those things that made a big roaring noise every time it started and stopped, that's a PTAC or a PTHP, and they're enormously leaky because they have to be removable, so they slide in and out of that sleeve, and they themselves have a very poor U value. So we've just said, yeah, you have to basically treat that as though it was a piece of single pane glass, and make everything else work with it. If your building facade has more than 1% of these penetrations, I just, you know, can see in the upper right, I did a quick calc. If a typical little apartment would have 135 square feet of wall area, and you had one of these PTHPs, that would soak up 5% of that area. So even considering that the side walls and some others will be add to the gross wall area, you're still going to be way over 1% if you use these for units. And we have other things in the mechanical room, just in the mechanical part of the energy code, discouraging their use because most of them are very inefficient. So we're moving away from that. People love them because they're cheap and easy, but that's too bad. And so we dealt with that with a footnote that's in this table, and clarifies that you have to calculate your wall with that area at 0.50 instead of 0.05. So 9-10 times the heat loss through there. A few little geeky things here. Remember we talked about that the cantilever concrete balcony, we've assigned a particular assumed U value to that. And at the bottom, you can see a couple of things where people have been asking, like, how do we deal with that garage level where you've got concrete columns coming down through the insulated floor below the units? And so we've got an assigned value for that to help people with the calculation. And we agreed that you would not need insulation directly above the electric utility vault to get around some difficult construction problems. Air barrier testing, the big deal is that it is mandatory now, and the test standard is 0.25. It's been 0.40 in the past, and this one kind of surprised me, but the State Building Code Council said, no, we're going for 0.25. So we have discovered that buildings that have hired an actual building science firm, and there are several great ones in Seattle area, to help with their facade design and supervised construction, always pass these tests with flying colors. The ones who fail have typically been people doing, with that have not hired a consultant and have been, just doing little 5/2 buildings or something. So take it seriously. They give you two options. Either you test the whole building, or you test a selection of stories you see there, plus 1/4 of the above grade walls. I'm not sure why that got in there, but I think it's going to be simpler for just about everybody to test everything at once. We do have procedures in place for buildings over 20 stories that you can't really test all in one go, and for multi-tenant buildings. So give us a call. And the idea is that it used to be that you could say, well, you could either have, have an inspector carefully examine things, or you could test it. But carefully examining things doesn't tell you where the leaks are. And the materials themselves and the assemblies are not a problem. They're well made. It's where one trade bumps into the work of the other trade or cuts through the work of another trade, and that really can leave things with nobody taking responsibility, or the different materials going through thermal expansion cycles at different rates. And those little gaps and holes are just invisible until you turn on that pressurization fan. I did a study several years ago about how this has all been working out, and interviewed several people in the industry at length. Some of the advice they have for the design team, the first one, like I just mentioned, hire yourself a consultant. It might be that you only need to do that for a couple of buildings, and then you kind of see what the details need to be and take it on yourself, but don't go cheap there. You really, once again, have a heart to heart with your insurer and see if they agree. The typical, a lot of places are still using sheets of typical details and specs that were created at the dawn of the computer age and are still in use. Kind of definitely look at those and bring those up to date to make sure your contract documents defend you. Notice that you can save money if you can talk your mechanical engineer into believing you, which is sometimes a challenge, that they don't have to leave this large allowance for replacing air leakage. That can downsize the size of the equipment and the size of the ducts in a really significant way. And if your mechanical engineer is not interested in that, find a new mechanical engineer. And don't do the. I think in the words of the Joe Steebrook, the great building science guy, don't do stupid things. They advise the I always love this picture, because I'm thinking that the contractor, the next thing he's going to say is, no, I'm pretty sure the building's behind us there. But I like the quote in red from one of the contractors. He says, it's not just words. You have to put in the schedule and the budget. And this whole testing thing is the good contractors are already on top of that. They have specialists that like ride herd on everybody and make sure there's schedule for it and everything. But especially when you've got design teams and contractors from out of town that are not used to this, gotta be really careful, and it takes a lot of upfront preparation and meetings to make it run smoothly. That vented roof, where just don't even go there. But all kinds of doors, range hoods in apartments, any kind of penetrations through that assembly by other trades are suspect. The parapet and the elevator shafts, trash chutes. There's some repeat offenders that came up when I interviewed these people, that each one of these was mentioned in several different interviews. Nick.
Yeah, well, a couple things. I just really like to encourage architects that actually that air barrier testing is your friend, and to really think of it that way, because like Duane said, some of these leaks are so small, you know, it's almost impossible to find them visually. And one thing to be aware of is a lot of times those places where air is getting out in the pressure test are places where water can get in when the building's operational. And so you really, really want to think carefully. So a couple thoughts per Duane's same old details that you've had since the beginning of time. A couple things. One of the things we've really discovered is that nobody is looking at paper drawings anymore in the field. So we used to do everything in black and white on all our details. And when that came to waterproofing, they were impossible to read. So you'd have, you know, 12 different black and white lines with different, you know, dots and dashes to try to convey all these different systems. And what we've really discovered is just adding a little bit of color to a drawing can make a tremendous difference to be able for people to be able to read and understand the different layers happening in terms of your waterproofing. So really encourage people to think about that. The second, I just put a clip from a project I was working on of the comments from those waterproofing consultants. And you really want these consultants. They, somebody like Arup or, you know, RWDI or Fourier, they'll not only look at your details and help you understand them, but they'll also go out to the field and catch things that you wouldn't catch yourself. And you know, the first most important thing for most architects, at least, is to make sure that things don't leak. So this is a quick example. One of the things you'll find with those consultants is they really like silicone sheeting. They're not as fond of caulking, and the reason is that the silicone sheeting is continuous and isn't nearly as prone to mistakes in the field, and also doesn't degrade as quickly over time. The second thing is that what you'll see is a lot of the comments from them is looking at things three-dimensionally, so looking at that detail and thinking about what happens top and bottom when all that waterproofing turns a corner or gets to a window frame or does those things. And they're incredibly good at finding those problems and really helping you understand where they are.
And Nick, your building right now is surrounded by lifts where they're like replacing all those seals, right?
Yeah, I hope not. You're talking about our headquarters. They're working on a bunch of different stuff, but yeah, I mean, some of that's real. I was going to say the last really important thing to know is that materials and waterproofing materials change quickly. There's a lot of incompatibilities that as architects we might not be aware of. So there might be some materials that don't adhere well to or do things well with other materials, and the consultants are incredibly good and up to date on finding those things, which you don't want to find out after a building has gone up. So use them, really use them. They're worth it.
Yeah. Here's a little one for you. Semi-heated spaces are, people are always angling for this designation, but those are places that have some heating but not much. And the only difference it makes in your building envelope requirements is that you don't have to do the insulation for the opaque walls. Everything else, the windows, the slab edges, that all has to comply with code, because we found that over time people will just move in a different function there, and then they'll say, well, we need some heat here, and move it up. And I just wanted to mention there what you see in highlight at the bottom is that we've made it clear that heat pumps are allowable as the heat source for those semi-heated spaces. But it might be like, you know, there's a big retail outfit that's got a garden store on the side of it that is not heated like the rest of the building. That's the kind of thing that works as a semi-heated. with envelope quality, I've heard from a lot of people in the experts in the field that the big thing is continuity first, that you just have to really understand in 3 dimensions where that inside air is separated from the outside air, and is it all done in a way that's going to last for 50 or 100 years. And working it out in elevation or even in section doesn't do it. You really need to look at how the corners of things come together. But you got to have communication early on. I've seen people with the plans up on a screen where the general was highlighting each thing with all the subs present, like who does this sealant and who finishes that gap. Those are important things to get worked out, and it just takes time up front. And then you got to watch it the whole time. And just remember, Dan, you got that air barrier test, and you really, really got to pass.
So this is exactly per what Duane is talking about. I mean, one of the things that we discovered at MBJ was just that first, a lot of the junior architects, a lot of people straight out of school or relatively recent into architecture, actually had no idea where the outside of the building was or the inside and where that line went. And as you get into kind of more complicated assemblies, that really can be problematic. Or it might be that several people on the team have different thoughts about where that air barrier line is. And so one of the things, we're a little old fashioned. It's not 3D, but we do plan section elevations a lot on all of our buildings as a way to understand them. And so one of the things we've started doing with our teams is asking them that all the plan section elevations have a red dashed line that runs through the drawings that shows where that air barrier is, because it's really complicated. And a lot of with rain screen or different things, it's really complicated. And you need your whole team agreeing and understanding exactly where that line is. So really encourage you to add that line because it'll tell you a lot.
Cool. And once again, you could use color to make that stand out. Note that we've bumped up the requirement for renewable energy, which of course on buildings just means solar. And so at the state level, it's a half a watt per square foot. For Seattle, it'll be 3/4 of a watt per square foot of conditioned area for all the floors of your building. And then there's additional renewable energy in the C406 additional efficiency credits table, and you might want to, once you've paid for a small system, the incremental cost to increase the size of that is much smaller than you paid for that first section of the system. So you might look at that as an economical way to get credits. And along with this actual solar on the roof, you have to get solar readiness set up on at least 40% of the net roof area. And the net roof area as defined in the code is the gross minus planted areas, occupied roof decks, mechanical equipment, service area for the mechanical equipment, skylights. So you take that net area and at least 40% has got to be ready for solar, and you might even want to consider making all of that net area ready for solar, because then you'd be set for the future. You have to allow for 4 pounds a square foot of dead load, and you have to provide a roof sleeve for every 2,500 square feet of roof for the cabling to go through. And if you want to know how big 0.75 watts is, look at the right-hand side of that column. That a 10-story building, that would be over half of the gross roof area would be to get to 0.75 watts. And you can see that at 20 stories, you've gone over what's can be accommodated on most roofs, and you'd have to start then working with some of our other options for for whatever portion of that doesn't actually fit. And note that once you're over 3 stories, you can't actually even occupy 100% of your roof area because the fire department needs certain walking area around the perimeter, and you need to have equipment access and some other things. So probably somewhere around the 14 or 15 floors is as tall as you could imagine getting and putting all of your required solar for Seattle on the roof. You could at the state level with just a 0.5 watt requirement, you could probably get up to 20 stories. Just a few things, basically you have to decide between ballasted systems and mechanically attached, and they have pluses and minuses. I've got there. The ballasted system is going to weigh a little more, which might get your structural, attention, but it's got way fewer actual penetrations through the roof. They, have these concrete blocks that fit into a little slot, and it kind of works. I've heard advice from some people that it would still move in very heavy winds, so you want to get it all restrained back up on the windward side for when you get your heavy winter winds, which for us would be the south. But if you're doing new building, you might want to look at the mechanically attached thing. There's more penetrations, but if it's, like I said, if it's new construction, the solar installers can work with the roofers and have that all done at one point. It gives you the option to have a little higher tilt on the panels. If you want to go that direction, just talk to your structural about wind things. There's this really cool company in Switzerland that makes panels that look really nice, I thought, in 30 different colors that have been, tested for 20-year aging and all that, that look just like wall panels, and they're fully functioning solar panels. Cost a fortune, but they might not cost a fortune forever. And for those, our rooftop things work really great for a day like this. It's the sun is high in the sky and you get a good angle. But when you really want solar, would be in the winter or in the early and late parts of the day, and that's where a wall assembly would work. So keep that in mind. There's also that you see on the left, they have systems out for use as balconies. I mentioned the C406 additional efficiency credits. You can see there the requirements for Seattle are 10% higher than the requirements for the rest of the state in terms of the number of credits. If you're used to the old system, don't panic by seeing these numbers. It's a different system. It's like a stock split of 6-to-1. So they basically made each one of the old credits worth approximately 6 of the new credits, but this is much more scientifically worked out at a national level now. This whole thing started here in Washington State and has made it into the national codes. But see where I've got it circled in blue there, the red 45 credits you need for an apartment building in Seattle. There are 3 envelope-related credits, and if you just got 2 of them, that would get you 44 of the 45 credits you needed. Reduced air leakage, which is not even the super duper reduced air leakage, but it's some, and the better envelope performance. And those, you can see the top one there, that just says that your total UA is 15% below the allowable. Might be able to do that. And for the air leakage, it just says that you have to have 68%. So you're basically saying reduce your air leakage by 1/3 below that maximum. So what you see in red there in the middle is that you'd have to get it down to 0.14 CFM of air leakage. I've noticed that a lot of curtain wall systems are already in that range, just because it's a very carefully engineered system. So if you really were careful with, the loading dock and the mechanical floor and some other things like that, you might be able to get down there without much problem. But just be aware, there's a couple of things. Air leakage is one of those things that potentially could cost nothing, but just be really clear that if you get to the end and you don't hit the 0.14, then you're going to have to come in and negotiate some kind of a fix, which you don't want to go for. Here's one thing for existing buildings that I'm intrigued with. There are secondary systems where you can take an existing building with single pane or even double pane glass and put these additional things on the inside, or for some manufacturers on the outside of the existing. I was howling this was developed with PNNL and some national lab staff. I was howling at them that it was going to have condensation problems, absolutely for sure. I mean, come on. But it turns out that it doesn't. And in fact, they finally sent me an email a few months ago and said, we did have a failure just now at one of our installations in Boise, and we're going out to see what happened. But they cleaned the glass. They put some desiccant in the middle to handle some changes in humidity in there, and it seems to be working. But look at on the right for medium office. There's a huge amount of energy savings possible for both the heating and cooling, and for the small office, you'll see there's some savings for cooling, but still substantial savings for heating by going with these systems. And you don't have to go in and rip out the entire window system or facade system. There's 4 different current players in the market that all have their own patented systems for doing this, and much less than half of the cost of replacing the whole thing. Just want to mention that if you're re-roofing, you do need a permit. It used to be that they didn't, but the reason we require a permit is so we can make sure that you do the roof insulation. You'll find that that's not that easy in a lot of situations because you've got, a doorway out of your penthouse at the top of the stair. You've got perimeter conditions and mechanical equipment, and we just have to. We'll work out things with you on those, but just be aware that in general, if you're re-roofing, you're going to be adding insulation. There are a few things you don't need to come up to standard with. So if your local 10-year-olds just knocked a ball through your window, you don't have to bring that up to code. You can just replace it like for like. If you open up a cavity in the wall or the ceiling, you don't have to bring it up to code. You just have to fill that cavity. If you replace a door, you don't have to put in a new envelope. That's saying if you replace a door with another door in the same opening. For alterations, air barrier testing is typically not required, and the reason is that it doesn't make a lot of sense for most alterations. But those big 3, change of occupancy or change of space conditioning, or in Seattle, substantial alterations, are, like I said earlier, that's where we're saying we're treating buildings as though they were new buildings, and then backing off slightly. And those you're going to have to go in and tighten up the building. And another great opportunity to hire one of our specialist firms in Seattle. So finally, just wanted to show that I had the slide up last time and said, well, even though we've reduced energy use in Washington State by 40% already, which is great, to get to our 70% reduction target in state law, That still required half. That 2021 code looks like it will have come in right around where those dashed lines are. So we've done a chunk of that. You can celebrate that, and you can just see that as we get to those last parts, it's going to be gets progressively more difficult to find things. But it seems like every code cycle we've been finding things, and we very well might just hit that target on target. So finally, you hate to hear it coming from me, but there is more to life than energy efficiency. If we can use this opportunity that we have when we're doing, when we're meeting these code challenges to make sure that, in fact, you have better sunlight and more comfort close to those windows and less emissions, that you're using systems that are going to last for a really long time and that look good, then that's going to help ensure the credibility of the whole energy efficiency things and make sure that we're using the change to take care of the humans that we're putting in and around our buildings. Nick, did you have any last words before we go on to the business part here?
No, I mean, I think this last one is the most important. It's definitely a yes and we're really finding that the increased energy performance actually comes with better comfort for the people inside the buildings. And so you can make beautiful places and beautiful buildings that are also energy efficient along the way, and everything can be better.
Cool. Katie, were there more questions queued up?
Oh, we have lots of questions, yes. And this last slide is actually kind of a good plug for the Lighting Design Lab. That's the whole reason the Lighting Design Lab came into existence, was all of this kooky new efficient lighting was coming out, but not all of it was great. So we were created to help people design energy efficient lighting that didn't compromise on these human values. And we are transitioning, for those of you that do not know us, to include other energy, electric uses, so heat pumps, and we will be a good resource for that. Questions?
Just a quick plug, I just wanted to add to that, you know, I have the Lighting Design Lab on all of my projects. So I use them pretty much every project I do, and I will say that it is worth its weight in gold. It really makes a big difference. They can do so much that at least we can't do, and they can do it. The things we can do, they can typically do them so much faster than we could do them, that it really makes for better, high-performing, beautiful projects that are better for the owners. So really, really appreciate the Lighting Design Lab.
Wow.
Excellent. And Duane, I saw that you had a slide that had the upcoming courses. Do you want to put that up, or do you want to do questions?
Go through technical questions first.
Yeah. Okay. First one, you kind of already addressed. Could you consider using secondary glazing systems to improve window systems for a retrofit? Yes. Okay. And then Cameron had, I thought, a good question. Do you expect buildings built to this new code will comply with the building performance standards, both Washington and Seattle, through 2050?
The interesting thing about the state building performance standards is that the expectation is that future legislators will tighten up those rules. And I don't know where that lands, but I did right now the state standards for several building types I looked at have EUIs in the 60s. And so buildings that are worse than that, and we have plenty of old offices that have EUIs still up in the 90s, and schools, some other things, those compare with EUIs for compliance with our current code, which are expected to be in the 20s. So even if they take that state standard and they squeeze down that, you know, to EUIs of 50 or 40, that would still leave all new buildings way better than that. And with the city standards, we're saying we're reducing the amount of emissions, but with new buildings, you're not going to be doing fossil fuel heating or water heating anyway. So your only remaining uses are going to be cooking and decorative fireplaces. And we have rules in there that are saying if you're doing commercial cooking, you can still cook with gas, but you have to bring in it for new buildings an electrical panel that is capable of supporting a switch to electric cooking in the future. So I think we're good.
Okay, and this question you might not be able to help with, but there are some other City Light folks on the call. And if you hear this question, go ahead and type in an answer if you have one. Are there any upcoming financial incentives planned by Seattle to upgrade buildings with single glazing? I don't know. I don't work in conservation anymore.
Maybe somebody's typing something in right now, but I can say that it gets complicated because the heating might be, in many cases, might be by gas.
Right.
In which case, City Light would not be able to help out with that. You know, if you're looking at a program that's going to impact things at scale, you can see that it could get pretty expensive to upgrade everybody's single panes.
Yep, for sure. And maybe IRA funds will help some. I don't know. I haven't looked at that too much. Next one. Oh, Steve has another question. Does the air barrier line shift due to shifts in outside temperature and humidity?
Well, I'll start and then Nick will finish. The air barrier is what it is. So where it is in the assembly, you might be talking about where the dew point would be, but we're trying to create assemblies that do not permit any condensation within the assembly. Nick?
Yeah, I mean, I'm not fully sure I understand unless you're talking about like in Florida or other places where humidity and temperature are different. But for Seattle, yeah, the air barrier really, we're trying to find that balance where you get the maximum insulation outside, where you get enough insulation outside that you're keeping condensation from happening on the inside, and you're keeping the moisture-laden air from the cold spots. So no, it doesn't shift. It's always in the same place typically.
My favorite spot for an air barrier is to like dispense with the insulation between studs entirely and have all the insulation as exterior insulation. And we've done that back when I was at NBBJ on some projects. And the extra bonus prize there was that it then left the stud spaces open for conduits and communication wiring and piping and whatever else, you know, because it was part of the conditioned space.
Mm-hmm. And the balance is always the thickness of the wall, right? And how much of your rentable you lose, right, to that thickness.
What's next, Katie?
All right. So when you're calculating the net roof area, I think they're asking, do currently installed PV panels are they excluded when you're calculating the net roof area?
Yeah, the not for the net roof area, but it is okay for solar panels, obviously, to be in any of that part of the area that's designated for future solar panels.
Okay. And then Sarah, she thinks this is a stupid question. I don't think it's a stupid question. Is there like a Cliff Notes type summary of all the changes from the 2018 code to this code?
There's posted online in the SDCI website. There's a tab for 2021 code adoption, and in there a document that's got the actual code language for all the code changes that we're proposing right at the moment.
Okay, and then Steve asked, is the re-roofing permit size qualified?
500 square feet. So below that, we're considering it just to be a patch or a repair or something like that. But once you get over anything over 500 square feet, you get a permit, and you have to show the permit people that you're putting in the installation if you need to.
Okay, and then does thin film solar panel, is it accepted? They're lightweight and typically do not add significant weight to the roofing.
I have been reading about thin film solar for ages and have never actually seen it. I mean, my thought in the future is that there will be something that comes, it looks kind of like a yoga mat or something like that, and you just roll it out and stick it onto the roof and plug it in, you know, and you're generating power. So far, I haven't seen that yet, but we're agnostic to what technology of solar you've got. So if definitely make sure it makes it into the local Sunday supplement magazine if you're doing thin film, because I think a lot of other people would be interested as well.
Hey, Duane, would it be on that? At least the thin film I've seen is a lot less watts per square foot. They'd still have to meet the watts per square foot requirement for the building, right? So you might need more area of PV.
Yeah, although it might be that you can walk on it, in which case you could just cover it, you know? It's right. To me, it's a lot of potential, but there have been some kind of technological things. So I haven't, in the analyses that I read on a regular basis, I haven't seen it mentioned for years.
All right, I have 3 more right now. Elise wants to know if the Washington 2021 code adoption is still anticipated for July, even though the Seattle one is delayed.
Yes, it's still, so everything out of Seattle city limits is going into effect July 1st. So you get your application, that everybody expects to get this big rush of applications in June, but Seattle will be later.
Okay, and Cameron wanted to know if there's a list of Seattle or Washington state companies that offer air barrier testing that meet the code standard.
We don't maintain a list. I've found that if you Google Seattle air barrier testing, you'll get quite a long list. And my preference is that you first Google Seattle building science firms, and then you'll get a shorter list, but still several alternatives that have really highly capable staff.
Good, and the last one so far, are there any special requirements or allowances for CLT construction?
There's I can't remember the name, but there's a terrific affordable multifamily project that just opened for Capitol Hill that used mass timber for columns and beams and CLT for floor systems. So they replaced what otherwise would have been concrete and or steel with those systems. And I think that is optimal. I have personal prejudice against use of CLT for exterior walls. The thought being that, you know, 4.5 inches of CLT is getting you, say, an R6 charitably, and yet you need to have like an R19 or 20 total. So you'd have to build outside of that thing an entire wall system with insulation and, you know, enough studs to support the finished material on the outside of it. So basically, all you would have done with this enormously heavy and expensive CLT is to replace the interior JIP board. So makes sense. So I would not, but otherwise we don't, we do not currently have an embodied carbon metric in our codes. There is a working group that's been established to start working through this between some advocates and industry people to come up with something internally in Seattle, and that I would expect to see some at least preliminary results within the next year, and we can start looking at it. It turns out that mass timber products are not as completely innocent as I had been assuming. So there's definitely some environmental issues there as well. So we got some things to consider, but CLT, I'm still advising you take it with a grain of salt for for some of the true believers. Was that it, or did we get one more?
Well, Jess wrote Heartwood, but I'm not sure what the context was.
Oh yeah, that's the name of the building on Capitol Hill. Thank you, Jeff.
Thanks, Jess.
And it's I was able to take a tour while they were just finishing up. But if you get a chance to go by, it's a good looking building, and it's going to be really energy efficient and not be using any above grade concrete or steel. Pretty remarkable.
All right, that is it.
You know what? We're finishing kind of right on time, so worked out well. You see my my address there, and there's Nick's and Armando to represent the Lighting Design Lab. But Katie, you want to mention the upcoming?
Yeah, these are all available to register for on our website there, lightingdesignlab.com. And one thing I forgot to mention at the beginning is this was recorded, and we'll put this recording up within the next week, and it will be the same for the rest of these. Now it says on this that the HVAC and water heating are 10 to 11, but I think those are both 10 to noon, aren't they?
Oh, yeah, that was
Okay.
my mistake. Yes, thank you.
Well, yeah, no problem. And for longtime Lighting Design Lab people, Sean's gonna come back for the electrical one and help out with Duane.
That's where you can go to find stuff, and where you can go to find the slide deck, and I think that's it. There's a survey out there for people as they exit. Is that right, Katie?
Yep, just when we close this up, it'll kind of pop up a little. I think it's 10 questions or less. It's really fast.
Yeah, well, at least say nice things about Nick. He's very sensitive.
Oh, there you go. Please help us be better. That's always good. Whack us
Thank
with
you
a stick.
both. Well, we won't send those off to you guys. We won't tell you when they whacked you. Thank you both for your help today. These are always so informative. People love these. So have a good lunch.
Thanks a lot, everybody. See you next time.
Pleasure.
Bye-bye.
Thanks, Nick.